Welcome to ClickMyProject.com. Let's discuss about the product. Our product is use of elliptic curve cryptography for multimedia encryption. The unique characteristics of the elliptic curve cryptography, that is ECC, such as a small key size, fast computation and bandwidth saving, make its use attractive for multimedia encryption. In this study, the ECC is used to perform encryption along with multimedia compression, and two ECC-based encryption algorithms are introduced and applied before and during compression. The first algorithm performs selective encryption on the transform coefficients during compression, whereas the second algorithm achieves perceptual encryption based on selective bitplane encryption before compression. The result of applying ECC to multimedia encryption are presented and analyzed with respect to the requirements of multimedia encryption. The encryption efficiency, compression efficiency, codec compliance and security level. It is shown that ECC is highly efficient and does not affect the compression efficiency, and accordingly can meet the multimedia encryption requirements. The recent advance in computer industry and communications create a market for digital multimedia distribution through open networks, for example, Internet. In open networks, confidentiality is one of the primary concerns for commercial users of multimedia contents. The typical examples of networked multimedia applications are video on demand, internet televisions, video telephony, and video conferencing. These types of appliances require a type of protection. For example, in video conferencing appliance, only the participation members are allowed to receive the audio and video data, and in video on-demand applications, the owner would like only the subscribers to watch the video with high quality. The protection of multimedia contents can be achieved using encryption algorithms. Let's see the flow of our design. So initially for our process we are taking RGB image. RGB images normally have 3 channels. So in this process our process supports only for the RGB channel. So we are splitting 3 channels separately, that is red, green, blue. So each channel is considered as a gray channel, and then we are applying DCT compression for the single channel, that is for a grayscale image, and then for the compressed image is processed by ECC encryption, that is elliptic curve cryptography, and after that the encrypted image is converted by its bitplane, and finally by the reversible process we are decrypting the full image. Let's discuss about the product. So this is the demonstration of our designed product. As we already discussed, our product is based on Matlab programming language. So we developed our product in Matlab 2013A. This is the main window of Matlab version. So there are a lot of windows in this. You can see this is the main command window. Here the files which are included in our process will be shown here. That means this is the current folder or current directory. So depending on the selected file, the details will be visible here. So this is the workspace. The temporary values in mat format will be visible here. You can open that and you can see the backend values, what are the processing with Matlab. So you can see there are similar names containing .m and .figure files. For example, main0.m, main0.figure, main1.figure, main1.m. So these files are representing .m files are always in Matlab programming file. So and .figure files are the GUI files, that means graphic user interface. So for our frame, our process is based on the frames. So our frames are designed in graphic user interface. So depends on this recalling program that will recall that GUI file. For example, see, I am running this file main0. So while I am selecting this will lead us to select which level encryption you have to do. For example, if I am selecting low level encryption, that will open another one file. So these all are based on these push buttons. So these are called the push buttons. So depend on the selecting push buttons and the back end, the push button functions are created. What the function should done by pressing this button. That means while pressing each button, that process which belongs to the button is placed in the backend of this guide frame, that is in .m file. So this is by the .figure file. As we already said, this is the graphic user interface. So I am selecting an input image. So the selected image will be visible here. This is called the access, and then I am now doing normal XOR based encryption and doing decryption of the same image. So this is the low level encryption method based on the XOR based encryption. So I am returning to the main panel. So now I am going to select the high level encryption. So at the high level encryption only our process, ECC process, starts here. So for this also I am doing an encryption. For that I am selecting an image. So I have selected the image, and the selected image will be visible in the access, and doing compression. As we already discussed, here we are compressing the image before encryption. So the compression can be done at any port. That means the compression can be done previously, that means before encryption, or it can be used during the encryption, or else it can be used at the end of the encryption. Here I am using before the encryption. So the image is compressed. The compressed image is here. The compression ratio, the bit PP results are shown here. So I have compressed the image, and then I am doing pre-process. In the pre-process, I am converting the image into grayscale, because as we already discussed, our process supports for grayscale format. That means if you even can split the red channel, green channel, blue channel, because each channel represents the gray image. And I am going to process ECC. So while I am pressing begin process, that will process that figure. So this is the encrypted image. So bitplanes conversion are here. So this is the ECC encrypted. These are the bitplane conversion. The same process will be reversely done here. So this is the bitplane reconstruction, and this is the recovered image. So this is the actually compressed image. I am doing ECC encryption here. These are the bitplane conversion based on bitplane 8, 7, 6 up to 1. So these are based on the layer by layer as bitplanes. So these are all encrypted image, and then I am bitplane reconstruction. So previously I have constructed the bitplane. No? So I am going to reconstruct the 8 bitplanes, and again I am getting this ECC encrypted image. So from that ECC encrypted, I am doing ECC decryption to obtain the original image. So this is all over our demonstration of our product. Thank you.